This is a video from section 12.4 in a Calculus 3 class. Let's take a look at 45. Let P be a point not on the line L that passes through points Q and R. Part A. Show that the distance D from point P to line L is given by D equals the magnitude of A cross B divided by the magnitude of A, where A is equal to the vector QR and B is the vector QP. Part B. Find the distance from point P, which is 1, 1, 1, to the line through points Q, which is 0, 6, 8, and R, which is negative 1, 4, 7. So let's take a look at a picture for part A for this to make sense. Notice how we have a line L, and we have points Q and R that are located on line L, and we have the point P, which is not on line L. Now, B is the vector QP, and A is the vector QR, right? And we want the distance, okay? We want the distance from point P, which is here, to the line L, and it ends here. And that line segment will form or will be perpendicular to line L. And I want you to notice how we have a right triangle here. And so we can take advantage of some trigonometry to find D. Let theta equal the angle between vectors A and B. Now, there's one thing we need, okay? So I'm going to put a note here. Theta is greater than or equal to 0 and less than or equal to pi. So I claim this formula will work as long as theta is between 0 and pi. Now, D over the magnitude of B is equal to sine theta. So if I multiply both sides by the magnitude of B, I get D equals the magnitude of B times sine of theta. But sine of theta is the magnitude of A cross B divided by the magnitude of A times the magnitude of B. So making my substitution, I get D equals the magnitude of B times the magnitude of A cross B divided by the magnitude of A times the magnitude of B. Notice how the magnitude of B's cancel, and we get D equals the magnitude of A cross B divided by the magnitude of A. And that's how we verify the formula for part A. And so one thing I want to comment on is the following. Notice how I make the restriction that theta is less than or equal to pi and greater than or equal to 0. Why? Because sine is non-negative between 0 and pi. If we look at a picture here, so here's the y-axis, here's the x-axis, right? If we're below the x-axis, that says sine would be negative, right? And that's going to contradict this formula because the magnitude of A cross B is non-negative, the length of A or the magnitude of A is non-negative, and the magnitude of B is non-negative. So we have to make that restriction that theta is between 0 and pi. Now, let's take a look at part B. Suppose P is the point 1, 1, 1, Q is the point 0, 6, 8, and R is the point negative 1, 4, 7. So A, which is the vector QR, is the vector negative 1, negative 2, negative 1. B, which is the vector QP, is equal to the vector 1, negative 5, negative 7. So if I look at A cross B, I get the vector 9, negative 8, 7. Okay? Now, the magnitude of A cross B, I claim, is the square root of 194. The magnitude of A is equal to the square root of 6. So remember, D is the magnitude of A cross B. I'm just applying part A to this problem, divided by the magnitude of A. And if I put everything together, I get D equals the square root of 194 divided by the square root of 6. And if I go to simplify this, I get D equals the square root of 97 thirds. And that'll do it for this video. This is problem 45 in section 12.4. Thank you.